Hello, myself Bhaskar Sharma from Department of Electrical Engineering and Arya College of Engineering and IT, Kukas, Jaipur. I am giving a video lecture on the topic of fault analysis of BTech 6th Sem. Now in this lecture we discuss about some topics, that is definition of fault analysis, analysis of fault conditions, types of fault, types of short circuit faults, factors affecting fault severity, methods and procedure of fault calculation, and the last one is the conclusion. Now in this slide we discuss about the definition of power system fault analysis. A fault calculation is the analysis of the power system electrical behavior under fault conditions, with particular reference to the effects on the system currents and voltages. Accurate fault calculation are essential for proper system design. Now, in this slide, we discuss about the analysis of fault condition. The analysis of fault condition and their effects on the power system is of particular relevance to such conditions as the determination of the required load and short circuit ratings of the power system plant, the determination of the braking capacity required of the power system switchgear and fuse gear, and the last one is the design and application of equipment for the control and protection of power system. Now in this slide we discuss about the types of fault. In electrical fault calculation, a power system fault may be defined as any abnormality of the system will involves the electrical failure of primary equipments, that is generators, transformers, bus bar, overhead lines, cable, and all other items of plant which operate at power system voltage. Now the second one is the electrical failure generally implies one of two conditions or type of failure, namely insulation failure resulting in a short circuit condition or a conducting path failure resulting in an open circuit conditions, the former being by far the more common type of failure. Now in this slide we discuss the classification of power system fault. First one, the classified the power system fault into two types, that is open circuit fault, and the second one is short circuit fault. In open circuit fault can be classified into three types. First one is one conductor open, second one is two conductor open, and third one is three conductor open. And in short circuit fault it can be classified into two types. The first one is symmetrical fault and the second one is unsymmetrical fault. Further, symmetrical fault can be classified into two types: three phase short circuit fault, three phase to ground fault. And unsymmetrical fault can be classified into three types. First one is single line to ground fault, second one is double line to ground fault, and the third one is line to line fault. First one, short circuit phases. The fault of this type are caused by insulation failure between phase conductors or between phase conductors and earth or both. The three-phase fault, which may or may not be earth, is the only balanced short circuit conditions and is the one used as the standard in determining the system fault levels or ratings. This is the basic diagram of short circuited as shown in figure. Now we discuss about the types of short circuit fault. The short circuit fault can be classified into two types. The first one is unsymmetrical fault, in which gives rise to unsymmetrical current, that is unequal line current with unequal displacement, called unsymmetrical fault. And the second one is symmetrical fault, in which it gives rise to symmetrical fault currents, that is equal currents with 120-degree displacement, is called symmetrical fault. This is the diagrams for the unsymmetrical fault, in which single phase to earth two phase to earth, phase to phase plus single phase to earth is shown as figure. This is the symmetrical fault diagram for three phase, where three phase touches the ground. Now discuss about the open circuit phases. The more common causes of this type of fault are joint failure on overhead lines and cables, and the failure of circuit breakers or isolators to close properly. Both the single phase and two phase conditions are of particular interest because they tend to produce unbalance of power system current and voltages. Now in this slide there are the various types of open circuit fault, where first diagram shows the single phase open conductor, second diagram shows two phase open conductor, and third diagram shows the three phase open conductor. Third one is the simultaneous fault. A simultaneous fault condition or a multiple fault condition is defined as the simultaneous presence of two or more faults which may be of similar or dissimilar types and may be at the same or different points in the power system. These types of fault occurring due to the lightning or clashing conductors results in a fault or each of the two circuits concerned. In continuation, the simultaneous fault condition is known as cross-country or earth fault, in which a single phase to earth fault at one point occurs coincidentally with a second such fault on other phase at some other point in the system. Fourth one is winding fault. This type of fault, which can occur in machine transformer winding and consists mainly of short circuit from one phase to earth. And the second one is the special problem from a protection point of view, because the current in the shorted turns can be very large while that in the remainder of the winding may be quite small. This is the basic diagrams of winding fault, where first diagram shows the phase to earth fault, second diagram shows the phase to phase fault, third diagram shows the short circuited turns, and fourth diagram shows the open circuited turns as shown in figure. The factors affecting the fault severity. There are main factors which affect the severity of fault, that is source conditions, second one is power system configuration, third one is neutral earthing, and the fourth one is the nature and type of fault. Methods of fault calculation. The information required from fault calculation, which gives the value of current and voltages at the specified point when a given fault condition is imposed on the system. A fault calculation can be achieved by number of methods, that is mesh current, nodal voltage method, network reduction technique, or simulation using a network analyzer. And the choice of method depends on the size and complexity of the circuit model. Continuation. The essential part of power system analysis and fault calculation is that which concerns the determination of equivalent circuit network for the system operating conditions. The fault can be subdivided into symmetrical and unsymmetrical fault conditions, and the last one is the classes of fault are analyzed by reducing the power system with its fault condition to an equivalent single phase network. Now the various methods for calculation of fault analysis. The first one is the Gauss-Seidel method, second one is Newton-Raphson method, and third one is the fast decoupled method. The fast fault calculation procedure. There are three steps for calculation of fault. The first one is its fault condition is represented by its positive current network. Second one is it is solved in terms of per unit quantity, and the third one is per unit quantities are converted to the actual values. Now discuss about the conclusion. A fault calculation is the analysis of the power system electrical behavior under fault conditions with particular reference to the effects on the system currents and voltages.